Okay, so I'm going to go over a couple of 3.5G notes here just to get you going on it. Most of it you guys have already done, just an extension of kind of what we've been doing. But yeah, before that, hope everybody's doing well. I'm kind of getting the technology worked out, but keep giving me your feedback and I'll try to get it squared away. Um, yeah, but hopefully this will work for you guys, and hopefully we'll be back to at least teaching new stuff after spring break. But I think we got the rest of this week planned out and we'll go from there. So this first one is just if we take an equation. So this would be 4b off of 3.5g. We're just taking an equation here, which obviously is a quadratic, and to try to get it into vertex form. Well, keep in mind your vertex form is just y equals a times x minus h squared plus k, right? Where h comma k is your vertex, okay? And a is equal to 1 over 4p, but the vertex there is the key thing. So really all we have to do to get this into the correct form is just to move our 7 over. Okay, so if we just subtract the 7 from both sides, and I guess I can flip this around for you just to make it match up a little bit better for you. Okay, we subtract 7, and right there you go. Okay, and then we can either put it into f of x or put it into y, since we do know that's a function. So that's really all you're doing, just quick one step just to kind of remind you that you can rearrange the formula a little bit to get it into the correct format that you're looking for. So this would be getting it into our vertex form. And obviously once you have it in your vertex form, that kind of delineates your vertex there pretty easily. And we'll get back to that in a little bit too when we add to it. Okay, so another one, just solving by substitution. You can see I got the graph down there. We'll get to that. But we did one of these the other day, but probably worth taking a look at again. So solving by substitution, or some of you may have called it equal values method, really the same kind of idea. But since they are both equal to y, we can go ahead and set those equations equal to each other. And then you're solving. Now, we have an x squared in there, so there's usually a good chance you're going to have to either solve by factoring or quadratic formula or completing the square. I'm going to do this one by completing the square, although you can also just do it with square roots. But that way, when you get to the other one, which I think 6c, you're going to probably want to use completing the square to do it. So I'll go to this one using that. So you're going to add x squared over and subtract 7 over. So if we add x squared and we subtract 7, you end up there, right? So if we kind of want to make this fit our quadratic form, we'd have a 0x there. Okay, now if we're going to complete the square, you're going to have to divide everything by 2. And then we also know we're going to want to add that 4 over, so I'll just do that in the same step. So now you're set up, right? You have it set up so that you can go ahead and just do your little formula, b over 2 squared. In this case, that's a 0. So pretty straightforward here so far, right? Add that 0 to both sides. In this case, it would actually factor out to this. So working with the 0 here obviously is pretty simple, but following these steps and using the completing the square is going to help you a lot with 6c, so that's why I'm kind of showing it to you this way. Square root both sides. X plus 0 is obviously just x, so we're left with plus or minus the square root of 4, which is 2. Okay, so keep in mind now, when you are solving systems of equations, which this is, more than one equation, you are solving for points. So we got an x value of plus or minus 2, but now you need to go back and find your y values. So if we take y equals x squared minus 1, which is probably slightly easier of the two equations, Well, all you're going to do is plug in a positive 2. 4 minus 1 is 3. And you would plug in a negative 2, which also going to be 3. So that's going to give you 2, 3, negative 2, 3 as your solutions. Okay, now why I had that graphed is just so that you can see it a little bit better, at least, what it is we're talking about there. And you can see there on that graph pretty well. There's 1, 2, up 1, 2, 3. So there's your point 2, 3. And that would be your point negative 2, 3 right there. So just keeping in mind that when we're doing that algebra, setting two equations equal to each other and solving, what we're really solving for is the 2 points of intersection on that graph. Okay, so that's 6D. So probably the biggest extension on what we've done so far is when you get to question 7. So looking at 7, we are trying to write this in vertex form, and then we want to state the vertex. So all the work we've been doing with completing the square, this is where we kind of tie it back into quadratic form. Excuse me. So we're going to want to just go ahead and make that f of x, y. And then we're going to follow very similar steps as to what we did with completing the square. So let's subtract that 37 first. But now instead of just it being by itself over here, because we're not solving, we're just rearranging it. Okay, when you were solving for x, you would make that y 0, right? And that's why you had nothing else there. But when we're trying to get it into vertex form, you still need the y there. So subtract 37, that's going to leave us with this. Now, same little magic trick there, okay? Or take that little formula, b divided by 2, and square it. In this case, that's 6 squared, which is 36. And same thing we've been doing. We're going to add that 36 here, and we have to add it to the other side to make sure we keep that equation balanced. Okay, clean that up real quick. It's going to be a y minus 1 there. And over here, we know that's going to factor down, because it's a perfect square trinomial, to x plus 6 squared, right? Okay, now here when we were actually solving by completing the square, you would go ahead, take the square root on both sides, and you would take it all the way down to solve for your x. But keep in mind, our goal here is just to get it into that vertex form. And we kind of talked about that in the first example today, where we just want that y equals a times x minus h squared plus k is the vertex form we're looking for. Well, we're already pretty close, right? So the only thing you have left to do is add that 1 to both sides. And right there you have it. Okay, that's going to fit our vertex form right there. Okay, now from there you can also pretty easily pull out your vertex. Your h is going to be a negative 6. Okay, and then k would be a positive 1. So there is your equation in vertex form, and there is your vertex. So it's actually, might even be a little bit easier than solving with completing the square, because you don't have to take it all the way through. Just be conscious of the fact that instead of putting in a 0 there for f of x or y, we're keeping that y there because we want to get it into vertex form. All right, that's about all I got for you today. We got 2 worksheets to kind of wrap things up. I'll try to set up a Google Meet for tomorrow. And then, believe it or not, spring break seems kind of odd, but you guys will have spring break coming up after that. And then hopefully I'll have some more information in terms of how we're going to proceed after spring break. But hope everybody's doing well, and keep giving me your feedback. Try to get to the Google Meet so we can kind of see how those things are working. That way we'll be ready to take off after spring break if we get the go ahead. All right, thanks guys. Hope everybody's well.